Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of PW Gulf. Students, today I welcome you all in your ultimate recap session where we are going to cover your complete chapter of Chemical Kinetics. Yes my dear students, you heard it right. The ultimate recap session of your Triumph batch is going on and it is a kind of a revision class where you can completely revise your topic, where you can create your short notes and where you can even create your cheat sheets. Yes, my dear students, this is going to help you out in your examination when you just need to revise in 1 hour or 2 hours. You can just directly look up to your notes and yes, your revision is done. So let's now start this particular session, but before that there is a wonderful quote for you people. Life is like riding a bicycle. In order to maintain your balance, you should move on, right? If you stop in between or if you put a pause in between or if you put a break in between, you can fall down, right? So same happens with life, my dear students. In order to keep a balance, okay, in your life, you should move on. You should not stop at a point because that is not you, okay? You will fall down. In order to, move in life, you need to keep moving on, right, everybody? So now with this quote, we shall proceed at today's class. And as I've already told you, we are going to cover your chapter Chemical Kinetics. Now ma'am, what are the topics that we are going to cover in today's class? So the very first segment that we are going to start with, my dear students, is going to be your introductory part. That is your introduction, right? The next segment that we are going to start upon is about your rate. That what do you refer to as rate of a reaction? Then comes rate law equation. Then comes rate law equation. What do you refer to as order and the calculation of order? After this, students, we are going to do integrated rate law equation. Integrated rate law equation. Moving on to your next segment, that is your fifth segment. We shall be covering what do you refer to as molecularity of a certain reaction. Okay, then comes your sixth is your pseudo-order reaction. Pseudo-order reaction. The seventh segment that you are going to study about basically is your Arrhenius theory. Arrhenius theory. And then the last topic will be about your collision theory. It's about your collision theory. So these are the segments that we need to cover in this particular lecture today, and I hope so you all are excited for this particular class. Let's start with the very first segment of ours, that what do you think is chemical kinetics? What do you understand by chemical kinetics? So my dear students, if I'll talk about what is chemical kinetics, it is basically a branch of physical chemistry that certainly deals with the rate of the reaction and the factors that affect that rate of a reaction. Yes. So how are we going to define it? It is basically branch of physical chemistry that deals with the rate of reaction, and the factors that affect the rate of that reaction, So that basically is your chemical kinetics. That complete study is about chemical kinetics. That what are the factors that affect it? Okay, so that all we study under your chemical kinetics. Yes. Now, over here, students, if you are listening very carefully, you have observed a word that I used is rate of a reaction. But what do you refer to as the word rate of a reaction? Let's understand this in depth. Students, rate of a reaction is defined as a change in concentration of either your reactants or your products per unit time. Even you can define it in a different way if I will be talking about in terms of pressure. So how shall I will be defining it? It is defined as change in pressure, change in pressure of reactant, change in pressure of reactant or product per unit time. So you can define it in any of the terms as per your given equation. Right. Now, if I have to write a general formula, how I shall be writing it? It is rate is equivalent to change in concentration upon change in time. Always remember that when I shall be talking about a general reaction, where R gives you P, R here stands for your reactant, and P beta here stands for your product. Yes. So over here, if I'll say R here stands for reactant and P stands for product, that means R is getting consumed in order to give you, in order to produce what? P, that is product. That means consumption of R and there is formation of product P. Yes. So how do we define in terms of rate? If I'll say it is always going to be negative change in concentration of reactant by change in time. Always remember, for reactant we shall be using a negative symbol over here, a negative sign over here. Why? Because reactant concentration is decreasing in order to create a product. And when concentration is decreasing, the rate should always be a positive value. In order to maintain a positive value, we are using a negative symbol over here. But if I have to write in terms of product, I'll be using positive. Now this delta stands for change. This is for product by change in time. Why I'm putting a square bracket over here? Students, square bracket is used for concentration terms. Whenever I am writing a particular concentration term, I shall be using my square bracket over there. I hope so this is clear and fine to each and everybody of you. Right? So this is how I define the rate. Right, everyone? Always remember one basic thing, that small d stands for small change. When you observe a small change, and when you observe a bigger change, you will put a, this delta sign. So this is used for a big change. This is used for a big change. I hope so this is clear and fine to everyone. So this is what is rate of a reaction and how it is defined. Now let's start to what is types of rates of reaction. Now basically there are 3 types of rate of reaction, and we have to focus majorly on the second type, that is the moderate kind of. So the very first type that I am talking about is very fast reaction. Then comes your second one, that is moderate reaction. The third one is very slow reaction. In your syllabus, my dear students, you have moderate reaction. This is in your syllabus. Here is your complete chapter based on. I hope so this is fine. Now let's talk about what do you refer to as, ma'am, very fast reaction. My dear students, very fast reaction is something which occurs in a very small interval of time, or I would say which is very instantaneous kind of a reaction. So when I'm saying it is an instantaneous kind of a reaction, or I would say which occurs in fraction of seconds. So that is basically your very fast reaction. And let me tell you, in very fast reaction, I'm really sorry. Let me tell you, in very fast reaction is there is no bond breakage, there is no bond formation. Only there is exchange of ions. So let's now discuss in detail. This reaction occurs very fast. Here, ions exchange occurs. Here only ions are going to exchange. Now let me give you a certain example in order to explain in depth. For example, I have AgCl plus NaNO3. That is going to produce your NaCl plus AgNO3. Positive, negative. So they are going to swap up, or even you can take the reverse kind of a reaction or whatsoever. Here you are observing there is an ion exchange that occurs over here. Right. Now coming on to your next part, there is no bond formation, or I would say formation or breaking occurs over here. Only exchange of ions are taking place. I hope so this is clear and fine to everyone. Now let's discuss about very slow reaction. Very slow reaction is like which takes infinite interval of time. That means so much time. One of the examples over here, students, is your rusting of iron. One of the examples, if you have to take, is your rusting of iron. I hope so this is fine. Now coming on to moderate reaction, let's understand this in depth. Students, in moderate reaction, basically this takes infinite interval of time. That means a particular interval of time. That means a particular interval of time. For example, if I am saying it is taking 10 minutes or it is taking 20 minutes, that means I am referring a particular time interval. So that is when you are referring something, when you are telling something that yes ma'am, it takes this much time, it takes this much time, that means you have that value over there. And when you have that certain value over there, that means it is taking a certain interval of time. That means it is taking finite interval of time, right? Infinite is taking it is a long time. Finite is when it is taking a particular value, right? Here bond breaking and bond formation do takes place. Let's take a general example of this in order to understand. That is formation of ammonia by Born-Haber's process. That is N2 plus H2 produces what? Your NH3. Yes, here what in actual happens, you do know that nitrogen and nitrogen are formed by the triple bond. They are attached by triple bond between them. Hydrogen and hydrogen do have a single bond between them. And when ammonia is formed, nitrogen and hydrogen are bonded and the bond just get broken up between nitrogen and between hydrogen and hydrogen. And a new bond is observed between nitrogen and hydrogen. So here in this particular case, bond breakage and bond formation do takes place. This is what is an example of moderate reaction. And in our syllabus, the whole chemical kinetics, the whole chemical reactions are completely based upon the moderate kind of a reactions. So we are completely now focusing upon the moderate type. I hope so this is fine and clear to every one of you. Now coming on to your next part, how do you calculate the rate of a reaction? How do we define or how do we calculate in terms of the given definition that I have told you? Let's assume that A is now converting into B as a product. Here when I am saying that when time t interval is 0, the concentration of A is A naught and B is 0 over here. Now let's understand with the general example, students. When I have not yet started my reaction, when I have just gathered all the requirements of the reactant that these are going to perform and give us a product, at that instant of time, if reaction has not yet started, product won't have been formed. Hence, it will not form. So we can say that product is 0 at that spot of time. That means when time interval is 0, it is A0, A naught. When time is t, students, it is going to be AT. Or in other terms, I will say it is A naught minus X. Now let's take a general example. If you have 15 chocolate students and I have to prepare a cake from that, I am saying just give me 2 chocolates. So you are giving me 2 chocolates. I'll ask you how much chocolates are left. So you will say 15 minus 2, that is 13. So 80 is that time that how much it is left over now. That means when something is used, so that 2 chocolates is this and this is 15, so 80 is 13. I hope so this is getting you. So if X moles are dissociated, you will form what? X only. If you're taking 2 chocolates, from 2 chocolates only cake will be formed, no? So X will be formed, that is 2 chocolates will be formed in other terms. Now let's understand, like if I'll ask you what is the rate of a reaction. If I'll ask you what is the rate of a reaction, students, the rate of a reaction is represented as dx by dt, always remember, because it is change how much decomposed per unit time. Now let's ask you what is rate of A, that is reactant. You will say it is minus dA by dt. So simple, ma'am. It is minus dA by dt if we are talking about reactant. So there is a negative sign, change in concentration of A. That is final. Final is A naught minus X minus initial. What is initial? A naught. Divided by what is final time? It is t. What is initial time? It is 0. So what are you getting over here? See, delta is still over there, right? You shall be observing that these cancel down and it becomes a positive value. So it is dx by dt. Okay. And I've already told you dx by dt is rate of a reaction. That means rate of reactant A is equivalent to dx by dt. Okay, that's fine. Let's now talk about rate of B. Let's now talk about rate of B. As it is a product, so positive sign will come. So change in concentration of B by change in time. Yes. Now what is the final value, my dear students? The final value is X minus initial value is 0 divided by final time is dt. So this is again dx by dt. Now that means if I am giving you a reaction in which, 1A gives you 1B at that spot of time, the rate of a reaction, that is dx by dt, is equivalent to what? Minus dA by dt. As you can clearly observe, this is equivalent to this and it is also equivalent to plus dB by dt. So this is how you calculate for this reaction when you have 1A gives 1B. And when I say that, ma'am, these number gets changed up, let's observe it. I hope so you have taken a screenshot. If not, please kindly take a screenshot of whatsoever I have written. Now let's see for this particular reaction when 2A gives 3B. In order to see over here again, let's take t is equivalent to 0, it is a naught and it is 0. When t becomes t, it will become a naught minus x, it will become x. But let me tell you students, the number that is written in front will be also written in front of x. In the previous cases, as it was 1, so we have not written, but here if it is 2, so 2 you will write over here in front of x, and here also in front of x, 3 will be written. The numbers that are written. In the previous case, it was 1, so we can directly write this as x, so it will be easy. Now let's observe, what is rate of A? Ma'am, rate of A is minus dA by dt for reactant, and it is minus d into what is final? Final is A naught minus 2x. Minus what is initial? It is A naught divided by delta T naught minus x. Now this A naught gets cancelled. This negative will become positive. You will get 2 dx by dt. What you will get? 2 dx by dt. What is this 2 dx by dt? It is minus dA by dt. What it is? It is minus dA by dt. Now in the same way, can we calculate for rate of B? Yes, ma'am. In the same way, we shall be calculating for rate of B. That is what? Plus dB by dt. Plus dB by dt. It is equivalent to what? Now see. Here we have positive sign. Delta. Final is 3x minus 0. Divided by final time is t minus 0. You will get 3 dx by dt. Now, what is this 3 dx by dt? It is plus dB by dt. Yes, ma'am. So, from these both equation, can I calculate my dx by dt? Yes, ma'am. If I want to know what is the value of dx by dt, we'll bring 2 over here. What you will get? Here you will get, ma'am, dx by dt is equal to minus 1 by 2, because if this 2 will come over here. So, it is like this, dA by dt. And for this case, if I have to write what is dx by dt, for this case, ma'am, dx by dt is 1 by 3 into dB by dt. Yes. So, can I equate this over here? So, dx by dt comes out to be minus half into dA by dt is equivalent to 1 by 3 of dB by dt. Yes, everyone? Yes, ma'am. Yes, everyone? So, that means if I am talking about a trick that you can use over here, what you have to do is, you know dx by dt, for reactant it will always be negative. Reactant is A, so minus dA by dt. If you have any number written in front of that, if it is 2 written, do it 1 by 2. See, right? And now let's see for product. Product, if it is a positive value, put plus dB by dt. If it is 3 written, do it 1 by 3. Isn't it same, right? So this is again a trick. So this is how do we calculate a rate of a reaction. How do we calculate rate of a reaction? Now few things that you need to keep in your mind. Rate of A is also written as rate of consumption of A. It is also written as rate of consumption of A. Right? And what is rate of B written as? It is written as the rate of formation of B. For products, we use a line that is formation. For reactants, we use consumption. I hope so this is fine. This is clear to everybody of you. You can take a screenshot of this as well. Moving on to your next part. Now we have what do you refer to as unit of a reaction. How do we define a unit of a reaction? See, always remember, we know that concentration is molarity, that is written as moles per liter. So this is unit of concentration. Now what is the unit of rate? Very simple, ma'am. Rate is equivalent to change in concentration by change in time. Yes, ma'am. Yes. So if I have to write the unit, what is the concentration unit? That is moles per liter. And for time, we are going to write second. So we can even write it as like this, mole per liter per second. This is the unit of rate of a reaction. This is the unit of rate of a reaction. I hope so this is also clear. Coming on to your next part, conversion of concentration to pressure. It's very simple, students. You very well know that PV is equivalent to nRT as per the ideal gas equation, right? And when I'll take this volume part over there, when I'll put this volume part over here, I will get P is equivalent to N by V into R into T. And what do you think is N by V? N by V is number of moles by volume, that is again molarity, that is concentration. So pressure is equivalent to concentration into R into T. So if you have something in concentration, if you need to convert into pressure, you can directly use this formula. Here the R value that you are going to take is, you can directly take it as 1 by 12 in order to simplify your questions. Right? Coming on to your next part, that what do you refer to as types of rate? Let's understand the types of rate. So basically there are 3 types of rate that you have to study. The very first is average rate. Average rate. Rate measured over a finite interval of time, that means over a particular interval of time, and is obtained by knowing concentration of substance at different time. For example, students, if you have this curve over here, let's say that, at a particular instance of time, if I'll say that, this is T1, so this is going to be C1 concentration, and if it is T2, so this is going to be your C2 concentration. Let's say this is 10, let's say this is 20, let's say this is 10, let's say this is 20, or let's take 200 and 100. Now, what is average rate? For reactant, it is minus, what is final? Final is C2, yes ma'am, 100. What is initial? Initial was 200 divided by, what is final time? 20 seconds, initial time 10 seconds. So this is minus 100 by 10, minus will get plus. So you will get 10 as your answer over here, right? So by this way you can calculate by plotting a graph. I hope so this is clear. Coming on to the next type is instantaneous rate. Instantaneous rate is calculated by drawing some tangents over here. And when you draw some tangents, basically, for example, if this is like this, you're drawing a tangent, calculate the value of theta. So tan theta is your slope, and that is going to calculate your rate over here. Coming to what is initial rate. So initial rate is when time t is 0. At that spot of time, the rate is referred to as your initial rate. Clear? Yes. Coming on to your next part, that what do you refer to as, ma'am, the rate law? Very important topic with regard to your any exam. If I'll talk about that is NEET or JEE, or I would say boards, it is a very important topic. Let's understand this. What do you refer to as rate law? The rate law equation is an expression in which rate of a reaction is given in terms of molar concentration of reactant raised to some power. Now that power can be same as the stoichiometric coefficient and even can be different, okay? It may or may not be same. Now let's take this certain example. For example, I am saying this is an elementary reaction. Consider this as your elementary reaction. Consider this as your elementary reaction, and for this elementary reaction, let's consider I have, rate as per rate law is directly proportional to concentration of reactant A raised to the power this number. For elementary reaction, these numbers are considered as their power, as their order. And similarly, the rate is directly proportional to concentration of B raised to the power this number, right? So when I'll put them together, this is rate is directly proportional to A raised to the power small a and B raised to the power small b. When I'll get this rid of this directly proportional sign, I will get rate is equivalent to K into A raised to the power A and B raised to the power B. So this is my rate law equation for this elementary reaction. And if I'll ask you what is the order of A, you will say small a. What is the order of B, you will say small b. And if I'll ask you what is total order, so you will say small a plus small b is your total order. Now this is when I took elementary reaction. Now let's consider when I'm not taking an elementary reaction. In that spot of time, your rate is directly proportional to concentration of reactant A raised to the power x. Now this A is not equal to x because it is not an elementary reaction. For an elementary reaction, only the values are going to be same. Coming on to your next equation, I can write down rate is directly proportional to the concentration of reactant B raised to the power y. Now let's get that together. Rate is equivalent to K into A raised to the power x and B raised to the power y. Yes, here you can clearly mention that A is not equal to x, B is not equal to y. So this is your rate law derivation. Let's now move on to the next part. Now comes the difference between the rate and the rate constant. Let's understand this in depth. Students, if I'll talk about rate, rate is change in concentration per unit time. What is rate constant, ma'am? It is represented as K. And you know R is equivalent to K into A raised to the power N, that is order, right? When you take concentration as 1, then rate constant is equal to rate. Rate changes with time, but there is an exception of zero order, and rate constant does not depend on time. Coming on to the next part, it depends upon the concentration except zero order reaction. Here, it will not depend upon concentration, but depends upon temperature, catalyst, activation energy. There is one question that is asked, like which of the factors are there on which rate constant depends. So it does not depend on time. Yes, the rate, yet it depends on temperature, catalyst, activation energy. Now coming on to experimental data in order to calculate the rate of a certain reaction, let's start with these values. For example, students, if they have given you such certain question and they are asking you determine the order with regard to A and B, how are you going to do? Now for the main reaction, just write down the rate law. You will say rate is equivalent to K into A raised to the power X and B raised to the power Y. So you are assuming that X basically is order with respect to A and Y basically is order with respect to B. Now, when they have given you such experimental data, you have to create such equations. Now, you are going to create three equations putting over here. You will get 2.1 into 10 raised to the power minus 3 is equivalent to K into A is 0.10 power X, B is 1 power Y. Now, for this one, we have 8.4 into 10 raised to the power minus 3 is equivalent to K into 0.20 power X, 1 power Y. Now for this one, it is 8.4 into 10 raised to the power minus 3 is equivalent to K into 0.20 raised to the power X, 2 raised to the power Y. Now you have to take any of the two equations. Let's consider the first and the second equation. Here I am considering first and the second equation. Let's divide it. So you will get 2.1 into 10 raised to the power minus 3 divided by 8.4 into 10 raised to the power minus 3 is equivalent to K into 0.10 raised to the power X divided by 0.20 raised to the power X, 1 raised to the power Y, 1 raised to the power Y. See, these are get cancelled, these got cancelled, these got cancelled, this goes on the tables of 4. So 1 by 4 is equivalent to 1 by 2 raised to the power X, hence students X comes out to be 2. In the same way, if I have to calculate Y, how I shall be doing it? Let's see. Let's now take our second and the third equation. When I am taking that, it's 8.4 into 10 raised to the power minus 3 divided by 8.4 into 10 raised to the power minus 3 is equivalent to 1 by 2 raised to the power Y. So this whole is 1. 1 is equivalent to 1 by 2 raised to the power Y. So Y comes out to be 0, students. Anything which has a power 0 always comes out to be 1. Hence 1 is equivalent to 1. Right? So here what is the value of X? It is 2. What is the value of Y? It is 0. So this comes out to be 2. Y comes out to be 0. So what is the order with regard to A and B? I have already written. It is 2 and 0. Clear? You can take a screenshot of this question as well. Now I am moving on to the next question. Coming on to one more question on experimental data. Here again they have given you have to determine the rate law now. Let's now assume for this particular equation that rate is equal to rate constant K into A raised to the power X into B raised to the power your Y. Yes, X is your order with regard to A. What is X, ma'am? X is order with respect to A and Y is order with respect to B. Now let's create the 5 equations that we can clearly observe. So it is 0.15 is equivalent to K into 1 raised to the power X, 1 raised to the power Y. Now the next one, 0.30 is equivalent to K into 2 raised to the power X, 1 raised to the power Y. Next is 0.45 is equivalent to K into 3 raised to the power X, 1 raised to the power Y. The next is 0.15 is equivalent to K into 1 raised to the power X, 2 raised to the power Y. Next is 0.15 is equivalent to K into 1 raised to the power X, 3 raised to the power Y. Now let's see any of the two equations that just get cancelled up. Let's see the first and the second one. They get cancelled up. Here you will get 1 by 2 is equivalent to 1 by 2x. So x comes out to be 1 over here. Now for the next one, where we want y, let's take out this equation. This cancelled up, cancelled up. 1 is equivalent to 2 by 3y. So y here comes out to be 0. Yes. Now how do you define rate law? You just put the values. Rate is equivalent to k into a raised to the power 1, b raised to the power 0. I told you something raised to the power 0 is always 1. Right? So what is the rate law? It is k into a raised to the power 1. So this is your answer for this particular equation. I hope so this is clear and fine to each and every one of you. If yes, kindly write it down. Coming on to your next question, now we are going to determine order with regard to reaction mechanism. So here they have given you a certain reaction. It follows this mechanism, you have to do this. Now see, in order to do such questions where they have given you mechanism, you should know that they will give you a main reaction. How to do this? They will give you main reaction. Okay, for main reaction, you have to write rate law. Do one thing. After this, students, they will give you, a slow reaction. You should know that slow reaction, students, is your elementary reaction. Elementary reaction is the one where stoichiometry is equivalent to your order. Elementary reaction is your single step reaction. Right. Now, when you are going to write rate law for this, compare this with the main equation. This is the second step that you need to do. Third step is they are going to give you an equilibrium kind of a reaction. In equilibrium reaction, you have to calculate K equilibrium where concentration of product divided by concentration of reactant. You have to do this kind of a stuff. Now coming on to your reaction mechanism, let's understand this. Let's do this, how you're going to complete it out. For example, if they've given you the major reaction, so you will be writing rate is equivalent to K into A raised to the power X, B raised to the power Y. We are assuming order. Right, now let's see the slow step. This is slow step. Let's write down the rate law. R1 is equivalent to K1 into A2 power 1, B power 1, Y, because it is elementary. Now compare both of them. We have B, we have B. We have A, but we have A2. That means we don't want A2. So what you're going to do is, if we are going to use this equilibrium reaction, what is K equilibrium? Concentration of product by concentration of reactant. What is product, ma'am? A2. What is reactant? A. A has the number 2 written, so that will become its square. Now, what is A2 value? Can we calculate? Yes, ma'am. Ma'am, from here, A2 value comes out to be K equilibrium into A square. Can we put this value over here? Yes, ma'am. If we'll put this, we'll get R1 is equivalent to K1 into K equilibrium into A power 2 and B power 1. Now, can we compare this with the main reaction? Yes, ma'am. A2 power 2, A power X. So, X comes out to be 2. B power 1, B power Y. So, Y comes out to be 1. Yes. So, this is your order. What is the overall order? It is 2 plus 1. That is, ma'am, 3. Clear? So, this is your final reaction. Kindly write this down so that we can move on to the next part. I hope so this is clear. Let's now come to the next part. In this particular case also, this is again a question with regard to reaction mechanism. Let's understand this. Now, for the main reaction, the rate law is K into P raised to the power X. Now, for this slow step, let's write down. This is R1 is equivalent to K1 into Q raised to the power 2, P raised to the power 1. For reactant, it is an elementary. Now, we don't want Q, we have to replace it. So, let's take this equilibrium reaction. K equilibrium is equivalent to product, that is Q. 2 is written, so it will become power, and P. What is Q square, ma'am? Ma'am, Q square will come out to be K equilibrium into concentration of P. Let's equate this over here. Yes. So, you will get what? R1 is equivalent to K1 into K equilibrium into P. And there is already one P over here. So, can we also write it like this? R1 is equivalent to K1 into K equilibrium into P whole square. Yes, ma'am. Now, let's compare this with your final reaction. So, P power X, P power 2. That means X comes out to be what, ma'am? Your 2. Clear? In such way, you can calculate order with regard to your mechanism. Now, this ends our order part. Let's now start with integrated rate law equation. Now, you should know in your syllabus, first order is there, zero order is there. Rest, you don't have to do in depth. You should know how to do it. So, let's start with first order kinetics when n value is given to you as well. 1. What is the integrated rate law equation and how do you calculate it? Let's calculate. See, A gives P. Now, at t time is equivalent to 0. We are considering it's A naught, it's 0. When time t is t beta, it becomes A naught minus x, or I would say it is AT. Yes. Now, let's see. We know that as per rate law equation, rate is equivalent to K into A power what? 1 because it is first order. So, let's consider this as a first equation. Now, you know as per differential law, what is rate? Ma'am, rate is minus dA by dt. Yes, ma'am. So, let's consider it as second equation. Now, let's compare first and the second equation. Let's now compare first and the second equation. Comparing first and the second equation, what we will get? k into a power 1 is equivalent to minus dA by dt? Yes, ma'am. Let's put this a over here and let's take the delta t over there. You will get k delta t is equivalent to minus dA by dt. dA by a, sorry. Now let's multiply everything with a negative sign. If I multiply everything with a negative sign, I will get minus k dt. Negative negative will become positive. I will get dA by a. Now as you know that I am calculating an integrated rate law equation. That means if I am considering this third equation, now I am going to integrate the third equation. Integrating equation third. Yes, when I am integrating this equation third, I will get minus k delta t is equivalent to dA by a. Yes, minus k will come constant and this is from time t 0 to t. So it is t minus 0 is equal to. Now this is written as ln to the base ea from a0 to at when you do integration, right? This comes out to be minus kt and this comes out to be what? ln to the base final at minus ln to the base ea0. Till here I want you people to write down so that now I can move on to the next page and I can complete this complete derivation. Yes, yes ma'am. Now let's see. We have minus kt is equivalent to ln to the base eat minus ln to the base ea0. When you have something in negative, subtracting sign, that becomes a divide value. So you can write it as minus kt is equivalent to ln to the base eat by a0. If you have to get this negative sign rid of, just do it opposite. It is minus kt is equivalent to minus ln ea0 by at. You have just inversed it out. So this becomes positive. You will get kt is equivalent to ln to the base ea0 by at. So this is the first equation. But by this you cannot calculate the numericals. So how am I going to calculate the numericals? Let's convert this into your log terms. Yes, so when students you are going to convert it into log, you will get kt is equivalent to 2.303 log to the base 10, that is a0 by at. a0 is initial value, at is your final value. So this beta is your integrated rate law equation for first order reaction. I hope so this is clear and fine to everybody. Now let's calculate and find out the half-life period. The half-life period. Ma'am, what is half-life time or half-life period? Students, it is T half or T 50%. What is that now? That means when half of the reaction has been completed. Okay, when half of the reaction has been completed, that means AT comes out to be your A0 by 2. So now let's put that in equation. We have KT 50% is equivalent to 2.303 log to the base 10. A0 if we have taken as A0 only, and AT is A0 by 2. So 2 will go above. Yes, now this is KT 50% is equivalent to 2.303 log to the base 10 2. Log 2 value is 0.3. That means KT 50% comes out to be how much? 0.693. So T half or T 50% comes out to be 0.693 by K. So this is also one formula for your half-life time. This is also your one formula for half-life time. I hope so this is clear and fine to everyone. Now coming on to your graphical part, let's do this. ln CT versus AT. CT is also AT. Final concentration, right? How do we calculate it? We know KT is equivalent to ln to the base E A0 by AT. Yes, that means KT is equivalent to ln A0 minus ln AT. Let's bring this there and that over here. So ln to the base AT is equivalent to ln to the base E0 minus KT. That means Y is equivalent to mx plus C. So when I am plotting a graph over here, Y is ln to the base EAT and this is C, that is this value is ln to the base E0. This is T, so the slopes comes out to be minus K. This is a graph, right? Let's see for the log now. We know that KT is equivalent to 2.303 log to the base 10 A0 by AT. Bring this 2.303 over here, what you will get? KT by 2.303 is equivalent to log to the base 10 A0 by AT. When we have something in divide, that becomes a subtracted value. Now what are we going to get? It is Kt by 2.303 is equivalent to log to the base 10 A naught minus log to the base 10 At. Bring this over there, bring that over there again. You will get what? Log to the base 10 At is equivalent to log to the base 10 A naught minus Kt by 2.303. Now, in order to plot a graph over here, again, we have log to the base 10 At. This complete value is C value, that is log to the base 10 A naught. This is minus K by 2.303 and here is T. This is the graph. I hope so this is clear. So now students, you can take a screenshot of this as well. The rest graph I'm giving you as a homework. These two graphs you have to think on your own and you have to draw. Right, now let's move on to the next part. This is about the units, a table that you can remember for 0 order, for first order, for second order. These are the units of rate constant on which questions are generally asked. So I have directly written over here for you people. Now coming on to 0 order reaction, that is also very important. Let's do that one. For 0 order reaction, when I'm saying n value is 0, how do you calculate a rate law equation? Let's see this. See, you have A giving us product P. So the rate law can be written as K into A power now 0 and something raised to the power 0 is 1. So we can say rate is equivalent to K. This is our first equation. The second equation that we generally write is minus dA by dt for reactant. Yes, ma'am. Consider this as your second equation. Now let's compare first and second equation as we did again for the first order reaction. In the same way here we have to do. So here we are comparing first and the second one. You will get K is equivalent to minus dA by dt. Yes. So here if I'll say for a certain reaction, let's do this. Here for a certain reaction, at time t when it was 0, it was A naught. Time t when it was t, it is A naught minus x. Yes, no? So here let's see. K is equivalent to minus. What is final concentration? A naught minus x. What is initial? A naught divided by what is final time? T minus 0. This gets cancelled up. You will get K is equivalent to x by t. X comes out to be what? Kt. If x comes out to be Kt, this complete values of At. Now here integrated equation is At is equivalent to A naught minus x. At is equivalent to A naught minus Kt. So this is your final equation. And if they ask you what is P, P is Bt. Bt is equivalent to x, so that is Kt. So integrated rate law equation for 0 order kinetics is At is equivalent to A naught minus Kt. If I'll ask you what is the half-life time for this one? Half-life time is half of the reactant has been converted into product. That means At is A naught by 2. So the formula is At is equivalent to A naught minus Kt. If At is A naught by 2 is equivalent to A naught minus Kt, let's bring this over there, bring that over there. You will get Kt 1 by 2 or half-life is equivalent to A naught minus A naught by 2. That is again A naught by 2. So T half comes out to be what? A naught by 2K. So this is half-life time of 0 order reaction. So this is half-life time of 0 order reaction. I hope so this is clear to everyone. Coming on to what do you refer to as molecularity? Molecularity, students, refers to as number of molecules participating in a certain reaction, generally in a elementary reaction. Now, can I ask you, can molecularity be 1? You will say, ma'am, how one molecule can participate? At least two molecules should, collide with each other in order to perform a reaction. No, students. There can be one molecularity also. But ma'am, how they will collide with each other? For example, if you have NH4NO2, here you have ions, no? So when you have one molecule, they have ions. So the ions can collide with each other and product can be created. Hence, molecularity can be 1. But it can never be 0, it can never be fractional. It can never be 0, it can never be fractional. I hope so this is fine. Coming on to what do you refer to as activation energy? So activation energy basically, students, is minimum energy. It is the minimum energy required, okay, to convert reactant to product or minimum energy required by reactant so that it can cross the energy barrier and convert into product. Let's understand how. For example, this is your energy profile diagram. This is your reactant and these are your products. Reactant requires some energy in order to get converted into product. So this energy which reactant requires, this energy which reactant requires is your activation energy, which is written by EA. Okay, and this is the energy barrier that it has to cross in order to convert it into product. Now let me discuss you what do you refer to as Arrhenius equation. Arrhenius equation beta is K is equivalent to A into E raised to the power minus EA by RT. Minus EA by RT here refers to as fraction of molecules participating in a reaction. Fraction of molecules participating in a reaction. K is a rate constant over here. A is pre-exponential factor. Because E is exponential factor, no? So in front of it is written, it is pre-exponential factor or also called frequency factor or also called Arrhenius factor, Arrhenius constant. Here EA stands for activation energy. And this complete term beta stands for the fraction of molecules that is participating in a reaction. Okay, now let's talk about the graph of this. So we know K is equivalent to A into E raised to the power minus A by RT when we'll do ln. So it's ln K is equivalent to ln A minus EA by RT. So when you are plotting a graph between ln K and 1 by T, this is ln A and this is minus EA by R. Sorry, 1 by RT if I'll say. This is minus EA. Okay, so this is a graph that you observe for Arrhenius equation. I hope so this is fine and clear to each and every one of you. And one more thing, if I'll tell you about temperature coefficient. So temperature coefficient is like after 10 degree rise in, temperature, the rate constant doubles. The rate becomes doubles. So this is also about temperature coefficient that you should read from NCERT. So there is one more homework for you people is to read this topic from NCERT. Read once from NCERT. If you have any doubt, you can write in the chat section. Coming on to what do you refer to as collision theory. So collision theory is something when the molecules collide with each other in order to give a product. Now that collision should be effective collision. And in order to give an effective collision, there are two factors that you should take upon. That is orientation and the energy through which they collide. Now, for example, if you have AA, if you have A2 and you have B2, one way for them is to collide is like this. And if they are colliding in such a way, so yes, it is an effective collision. It is 2AB produced. It is an effective collision. It is an effective collision. But let's consider they are colliding like this. A2 and B2 are colliding like this. So this is not an effective collision only because only one molecule is responsible. So for a collision to be effective, they should be like, they should be properly oriented, they should be properly aligned and they should have proper energy in order to collide it. So two factors are responsible for the collision theory, my dear students. Rest is a theoretical part that you can read about collision theory in your NCERT. So students, this was all about your chapter Chemical Kinetics and it was a one-shot revision session of your Chemical Kinetics. So my dear students, I hope so that this video was helpful to you people and you were able to understand that what do you refer to the terms like rate of a reaction, that what do you refer to Arrhenius theory, collision frequency. And one more thing is like you have to tell, there is one homework for you people again, you have to tell me in comment section an example of pseudo order reaction. Let me give you a hint of pseudo order and in the next lecture that I am going to have, I'll ask you again this question, I'll deliver the answer for you people. This is a homework question for you people so that you can at least let me know that whether you know the topic or not. As you very well know, it is a revision session. So this is also one question that I want you people to answer so that I can get that how much you have studied, right? So you have to tell me any one example of pseudo order reaction in the chat section and in the next lecture I shall be discussing this example in detail as well. But let me give you one quick, hint about it. Pseudo order reaction is a reaction which assumes to be something else, but in actual it is one. Pseudo is something like, for example, it is a fake smile, right? So that is pseudo smile. Fake happiness, that is pseudo happiness. So yes, when the order is something else, but it appears to be one. So that is what is pseudo first order reaction. You have to name any of the two examples in the chat section, and we will be discussing in the next lecture with your next chapter. I hope so this video was helpful for you in order to revise your complete chapter in one go. And now I will be meeting in the next lecture with the next topic, with the next chapter. Till then, keep smiling, keep learning. Thank you so much, my dear students. Take care of yourself. Bye-bye.